Hello, everybody, and welcome to our webinar here for May 6th, 2025, Who Leaked the Admin API Key and Other Non-Human Identity Nightmares. We are glad to have you here. A little bit of housekeeping up front. We'll make introductions here in a second, but we invite you to be interactive on this call. Please use the chat. Please use the questions as we go. In fact, we want you to interact with us so much that we're going to ask you a question you can answer right now in the chat, and that is, where are you coming from in the world? Where are you sitting right now that you're watching this? I, for instance, am in Chicago, Illinois. And who am I? Well, I am Dwayne McDaniel. I am the developer advocate here at GitGuardian, and I'll be your host for today, hosting our awesome guests. And let's just go in order you're on the screen. So, Mattias, where are you in the world?
Hey, Dwayne. Yeah, I'm based in London. I'm a former platform lead. Did a lot of consulting in my life as well. And over the last couple of years, I moved towards the security side, and especially identity security is a big part, as I was part of NHI, which is now part of CyberArk. And within CyberArk, I focus mainly on workload identity, especially around like open source things like Spiffy and Spire.
Excellent.
Hello, everybody. I'm from Bordeaux, France, city of wine, if we have any wine enthusiastic in that channel. I was, for the last 3 years, developer advocate for runtime security project called Falco, which belongs to the CNCF landscape. It reached 2 years ago the reduction level. So it's pretty much a standard, a de facto standard for runtime security, for Kubernetes orchestrators, for containers, virtual machines, and so on. And before that, for more than a decade, I was SRE/DevOps. So I know what it is to manage applications in production. I did, for example, 6 years of on-call.
Excellent. Well, thanks for being here. Thanks for doing this. And thanks, everybody, for answering. So we got people from Texas, from Switzerland, from Kenya, from Argentina, Jamaica, UK. Wow, we got all over the world here. So thanks for joining us. And the replay will be available to answer your question up front. So if you want to send this to your friends later, we'll let you do that. But let's get to it. Let's dive in. Because as you can tell from the name of this, we're talking about responding to an incident related to a secret, or in this case, an actual admin credential. So I think maybe some of you have been here out in the world. I know our guest here definitely have. But 1 in the morning, an alarm goes off, and you're on call, and now you have to figure out how to deal with this situation, a Postgres credential. And well, as we jump into this, we actually have a poll that we would love to know if you've ever actually been in that boat. So let me put the first poll up. You've ever been on call, and that is a published poll. There you go. So now you can go ahead and answer that in the interface. But Thomas, I'm just going to go to you first here. You get an alert like that. What is it that you need to know? What are you going to do when you get this?
It's half an easy question and half a tricky question, because first, it will, of course, depends your procedures, your workflows, and how you manage that kind of incidents in your company. But there are some basics we all follow when we have this kind of alert. But the first one is to be alerted and trigger the procedure, trigger the right persons that will take care of that, who will take care of that. Take all informations about which credential, which secret has been leaked, and which permissions are related to this secret. It's often complicated, but it's really important to know the scope, to know the context. And then we need to fix that by doing some rotation, by replacing some passwords, but it might also mean you will have to restart applications in some orders. You may have to restore some data and so on. And after that, you have to be sure or not this secret has been exploited or not. Find all in your all logs, in your security audit logs, if these credentials have been exploited or not.
I mean, to put that another way, we were talking about the credentials at the core of this, but we're really talking about what it's accessing. Like, what does this thing go to? Like, that's that core question, because not all assets are created equal. I think that's the first question a lot of teams have out there, and I know at CyberArk that's something you're helping people sort out there, Mattias. So your thoughts on like this general order of operation that Thomas laid out?
Yeah, and it happens a lot, and kind of where people start to look into is like trying to centralize some of those things. Think about Active Directory service accounts. Think about all of the secret vaults that are out there. It's trying to have like a central place to combine them in, and it's really hard to figure out how like to which a credential has access to in general, because like to give an example of an Active Directory service account, which I've worked with like many times. In essence, it's just a username and password, but it's been used by machines, and they can have access to 5 different services without you even knowing that they have access. That without you actually knowing in a really easy way to have access to these kind of things, and you want to have like a centrally managed solution for that kind of thing.
So I want to make a point of clarification, but before we do that, thanks for everybody for voting in the poll. It looks like most of the audience, 50% has never been on call, 25% has been in previous life, 3 people in the audience are on call right now, and that's their entire life. So this really, we're hoping to help you, and then everybody else does a rotation sometime. But the clarification I want to make is, we're talking about NHIs in the title here. We're talking about secrets immediately. We kind of dove into that. So let's map that together. We see NHIs as a very important topic to deal with, but at the core of any NHI, these service accounts, these Kubernetes clusters, the things you just mentioned there, Mattias, all of those at their core have to have some way to authenticate. So it's the same way that you are not a password, but you have a password, and that's what lets you as a human interact with, authenticate to a system to interact with it. All of these other things that aren't humans, and we're not here to philosophize on what is or isn't a non-human entity under the strictest definitions of it, but I think we can all agree that if the key that it's using to get to a Postgres database gets leaked, well, that's something we need to tackle. So really, there's 2 sides of this coin. There's the secrets security, and GitGuardian, we've been talking about that for a long time. You've probably seen other webinars from us or papers about that side. But this NHI governance, like how it's used, that's fairly new, and that's the conversation that we really want to steer around here. We're not the only people having this conversation out there. We're not the ones defining NHI. That is actually folks in the world like Gartner, but more importantly, folks like OWASP. OWASP put out this top 10 for non-human identity risks in 2025. They put this out in December, I believe. So let's take a second, just reflect here. And I know both of you have some stories. So rather than read this off to you, like improper offboarding, like not having a plan for, like, for instance, a human being, I have an offboarding plan. Like, my company will eventually take my rights away when one day I retire. I hope that's the situation. That's how I exit the company. But rather than read that list to you, I know Thomas and Mattias, you both had stories that kind of encapsulate like all of these pieces. So not just the secret leakage, which again we've been focused on a long time, but like the nature of the secret and the fact that we didn't isolate it to a single environment. Like now we're using the same secret across multiple resources, and humans actually getting in there and acting on behalf of these machines in ways that weren't expected.
Yeah, and I have actually a really concrete one, and I'm might even hit bingo by kind of covering all 10 of the OWASP kind of thing. But the concrete story I had, I was doing consulting for one of our customers, and I was leading a platform team, Kubernetes platform team. And within that Kubernetes platform, we were using credentials because like we still need to gain access to things running outside of a Kubernetes cluster, and there are many different reasons on why that's required. And one of my engineers was doing an enhancement to the platform, and what they did is they pulled like some of the secrets from the secrets manager, because we were using a secrets manager, pulled them down locally, and then did some testing and like made sure like his enhancements worked. and then some kind of like just slipped in. They committed everything to Git, and with that, also by accident, they committed like all of these secrets and credentials. Luckily, it was a private repository, so like it was not like immediately fully available to the public, but still like we need to go off from the moment that even it's a private repository, it's like out there, it's not secure anymore. Luckily, we had like a really great culture, and that engineer immediately spoke up. We started brainstorming on how to tackle this, because like there is also like a whole procedure that needs to be dealt with. And one of the main problems that it starts with like, look, a lot of these credentials is they need to be owned by a user, not necessarily a service. They are owned by a user, even though you're using them for a service, which is, in my mind, already like discrepancies and makes it really hard to juggle all these kind of things. So we had to start contacting the right user for that kind of to know like to which the credential had access to. We had like a whole list already in our documentation, luckily, that we knew this already. But then we had to talk to that user to generate a new credential, because we couldn't revoke yet the old credential. Otherwise, like it would fully incapacitate the platform and cause downtime. So we generate a new credential. We started to update that one. And then we found out that we were not only using that credential in development, but the same credential was being used in production. So like we had to figure out like not only to deploy to production development, but also like to production at the same time, because we were using the same credential across multiple environments. We then like rolled this out to development, tested everything. We made sure that like the new credentials was like being used, and we did then like an emergency rollout to production that same day. And then we were able to terminate and completely get rid of like the old credentials. So like all in all, like the compromised secret was out there for a few hours. Luckily, it was only in the private repo, of which we also rewrote the history. But again, if once it's out there, it's out there. We rotated the password, and like maybe the security impact was not that big, because like we had a good control over like all of that. But it still took like 3 to 4 people like half a day to like make sure that everything was rolled out correctly, that we didn't cause any downtime by doing things in a rush job kind of thing. And like that's 3 to 4 people that could do better things than attending like a security thing that like shouldn't be there at all, kind of.
Well, thank you for that. And yeah, I think you did hit bingo on that, except for the human use of it.
No, I did, because that's what the developer was using.
That's right. That's right. Sorry. But that, Thomas, on our work on preparing for this, you had actually made a really astute comment on like human use of NHI is weird, but it also speaks to this world where like human beings have ways to like multi-factor authentication and ways to other assert that they are human in there. I mean, you have a story, around that, right?
Yeah, I will talk about the story later. Okay. I have a pretty similar story to what Mattias just told. Years ago, I worked for a company. I will not say the name to protect them, but by just searching the name of this company in the search text, in the search function of GitHub, we discovered a developer who left the company a few months before. He basically tried to back up some of his configuration by pushing some folder in a public repository, and he missed some hidden folders. On Linux, when you have a dot at the beginning of the name of a folder, it's hidden in your graphical interface by default. And sadly for the company, in one of these folder, there was a file containing some access and secret keys for Amazon. So it was publicly online for at least 2 or 3 months. Fortunately for the company, these credentials were really well scoped. They were just able to push data on S3. They were not able to download files. So nothing has been extracted. This is a good point. But the guy didn't want to leak some data. He just wanted to save a well-designed configuration for his Node.js environment and so on. But just with git-a, it was just enough to push and give it publicly unavailable. This secret. We moved it, and that was done. But yeah, that kind of things is really might happen often, especially when you don't have MFA to protect.
That's what I was getting back to. So both of those stories, like the commonality of it is, it doesn't feel like that's insider threat. It doesn't feel like this is something done maliciously. These are accidents, and we've always made that. We have that belief here at GitGuardian that the vast majority of these secrets that are leaked are just done because humans. We're humans. We have errors.
Yeah.
Now, I did want to focus in on a few of these and some of the data that we have from our State of Secret Sprawl report that showcase like the extent of these problems. So to move on to that first one, long-lived secrets. We know this is a problem. If you read our State of Secret Sprawl report, we look at every commit that hits GitHub Public and see if there's a secret in it or not. We've been doing this for years, and this year we went back and looked at a subset of the ones we had found to be valid in 2022. Or I'm sorry, in 2022. And I think it was about 11,000 of them. The exact numbers in the report. You have to go read that. We can link here in the chat. But in January of this year, we took that same subset and tried to validate them, and 70% came back as valid. So while the developer, we're human beings, we're going to slip up, we're going to get it out there. This is kind of horrifying that we're leaving these long-lived credentials out there exposed to the world for a very long time. And I can only imagine the ones that we don't see. There's all sorts of stories of people finding like 5-10-year-old or 5-year-plus-year-old keys and using them, like the Toyota incident from a couple years back. But is this common from your perspective as well, Mattias? Like, I know at CyberArk you deal with a lot of keys and rotation policies. Is this like a common state you're seeing out there?
Yeah, I'm not surprised that this is the case. Like, what we see a lot is we see more and more people luckily adopting secrets managers. But what we see as well is like there is kind of some silo happening around that. So like it might be possible that like each development team almost have their own secrets manager. For example, you end up with like 100 of secrets managers kind of thing in your company, and each managing their own. But still, like your application needs to be able to consume that secretive data. And what gets stored in a lot of these secrets managers is like those long-lived keys, like that are valid like almost indefinitely or like a really long lifetime. And together with that is like a lot of applications are not prepared to be able to work with like something more dynamic, like something shorter lived. I can update the secret in my secrets manager or somewhere else, but if my application isn't like flexible enough that it automatically can read that like updated secret and keeps on using the old secret, like I cannot like remove that old secret because my application is still relying on that for business continuity. So like you need to have like that whole automation and that whole orchestration fit in by when a secret gets like updated, that you might like restart or reload your config for your application and make sure that it can like read that thing. And luckily within like the more cloud native systems like Kubernetes, that it's a lot easier to start doing that, because like there is like these informers, these listeners kind of thing that automatically can inform my application to either like just bring up a new instance of my application with the new secret and remove the old instance of the application, or maybe even my application itself is smart enough to automatically detect like the secret is changed. But like it's still like a whole coordinated thing that needs to happen, and that takes not only coordination from the secrets manager but also coordination from the application perspective.
We got a quick comment there in the chat, and keep them coming, folks. Please use the chat. Human nature, to an extent, to follow the if it ain't broke, don't fix it paradigm. But this can include not changing secrets, as there's a fear that it might break something.
My comment on that is like, if it's painful, do it more. Yeah. It's like it's literally like I come from like the SRE background. It's like when deploys are painful, do them more and do them more regularly kind of thing. And in my opinion, secrets fall under the same motto. Like if it's painful now, like you just need to do it more, and you need to design a process around that one.
Sure, if you have any thoughts on that, Thomas.
Yeah, it's really hard for a lot of companies to be sure one secret is not used in other places and be able to orchestrate the change. For example, if you disable a password for a database, you have to orchestrate all the reloads, even some restarts in all your fleet of instances, images, containers, or else. It might be tricky. It might create some disturbance for your end users if you didn't think about that from scratch, from the beginning of your project, of your application. It can be really hard, and this is why we see so many things. For example, I saw, it was totally stupid, but we used a famous monitoring SaaS system, and to orchestrate that, to deploy things with Terraform, we used the API key from someone who left the company 2 years before. Just before we knew we had to change this secret in so many places, so many things could break if we just make the disable the key. So it was like that for 2 years because no one wanted to take the responsibility to do it.
That responsibility is key in that. Who owns this in the process? And that's something we wish I had a magic wand that could just answer that for you, but that's something you're going to need to talk about inside your companies. Moving on, sake of time, this is a great discussion. We posit that part of the reason that it takes so long to rotate these secrets, Vlad, is like that exact sentiment. We don't want to break it, but that's because we don't know how it was set. If we knew exactly every permission that a secret had, it might be a little easier and a little quicker to swap it out. And you can't auto rotate if you don't have that ability to sense that. Related to that is this idea of over permissioning, and that's one of the other ones on the top 10 is over permission NHIs. We were kind of horrified by this in the report. Again, the State of Secret Sprawl report. 96% of GitHub tokens we found had write access of the valid ones we could test. Why are we setting permissions this wide? Thomas?
I can start, yeah. It's not a surprise, once again. When you are, if you take back from the developer's perspective, you are there to develop some unit tests. You are there to develop the workflow for your CI. If you are lucky enough, you can test it locally, but locally you have full rights, full permissions on your machine, so technically it should work more easily. But once you push that into your GitHub or GitLab workflow, almost 9 times over 10 it will fail because you mess up with some things really related to your code base with your test, and also because of lack of permissions. So at the end, you just give all permissions to your CI, to your token, to your key, and just to fix it. We saw that same phenomenon way before the containers. You remember when someone without a lot of skills about administration, system administrations, we got a lot of folder and files with 777 permissions because it was easier for the developers to just set the chmod like that and be sure their code will run. We have a lot of issues, of security issues, but it was easier, and for a lot of people, it was the only way to make it work. It's a lack of skill, and when you read the permissions required for your CI, and when you read the docs from GitHub and GitLab, it's quite hard to understand what are the scopes for each permission. It's not like read, write, and exec like we can have on a regular file system on Linux. It's much, much more complicated, and sometimes some permissions contain a lot of actions, even if they are not really relevant with your exact need for the moment.
And it fits also into like recommendations. It's like I feel like within all our services we need to get better at like recommending to people like, hey, you have like these credentials, might be valid, but like you're not using like these things, maybe scope them down. And I know like cloud providers like AWS and GCP definitely do this, for example, and they make these recommendations. Like we need to see this more across like a lot of like our other services like GitHub and stuff like that.
Exactly what I was going to chime in and say. Like, I wish that these services were as simple as just 755 and it works, or 777 if you want it to be completely unsafe. But it's thousands of permutations. Like more, I think somebody said it once. Like, there's more stars in there's less stars in the galaxy than there are ways to set your GitHub tokens. I think that's an exaggeration, but it just makes this thing hard. But you're right. Better guidance is definitely needed. Speaking of better guidance, it's 2025, and we couldn't have a webinar and not bring up LLMs and not bring up AI into this. So we would hope that, like, with better AI and advancements there, we would be getting better at this. But it seems to be that it's making things worse, at least for the data we're seeing. Part of our report, and again, how we did this is in there, but we went through and looked at the fingerprints of code, say like, well, this is clearly Copilot's fingerprints are all over this thing. In those cases, you were more likely to leak a secret. Again, kind of horrifying, because we're like hoping that people will refine their security practices with AI, and AI can help with a lot of things. Like, but it seems not to be helping with this. Is this in line with what you're seeing over CyberArk?
Yeah, definitely. I saw somebody post on LinkedIn earlier today. Like, I asked my LLM that my OAuth was broken. It recommended to switch to API keys. So, like, these kind of things, like LLMs, they learn from like what's already out there, and if when a mistake is already out there, like it will repeat that same mistake. But also, I feel like it's almost like you get like into two major classes of like how AI gets used. Like you have like the experienced developers, they've been through like their learning curve already, and they know how to do stuff. But then like they start using AIs, and like you think, oh, it's there, it works, let's go to the next thing, and it's good enough, and they might miss something. Is it laziness? Is it like carefulness? Like it doesn't really matter, but it happens. The second thing is also like what AI really helps is in getting like full-blown SaaS services even get up and running within hours and days for a novice developer, where you normally used to get like to even do a hello world, had to read through like manuals and things, and then you just had a hello world, and like it really took like a long time to get up and running. Now these like kind of developers that are new to development, they can use AIs, and AIs generate like such good working examples that it seems to work, but it's like very insecure. And then like that's where it starts to break down. Then they commit everything, and then people start kind of misusing and exploiting like the things that are out there, and they don't even know like that they made a mistake, because like they are really new to it, and they need to go through it, where like previously like they read their manuals, they read the best practices, and like they made sure like you were following the best practices.
And Thomas,
I totally agree. With this trend we have about vibe coding, a lot of people without any knowledge about the basics are developing new stuff. It's fine. It's good for them, especially. It's right, but they are losing all knowledge we compiled over the years to know how to secure at minimal the applications. So it's easy to create a form, an online form, but in your backend you will not have any sanitization, any control over the inputs, for example, just because the most of the example of the generated code base, you are using basic example from all over the web, which doesn't contain by default all these elements made for the security, because both of these examples are there just to explain the algorithm, the basics, but not the security best practices. And of course, when you develop something from A to Z only with AI, with some LLM prompts, at the end you may have a running project, but you don't have any control over it, and you don't know exactly how it works. You don't know. It might use some ACT libraries, for example. It might exfiltrate without any control some secrets outside, but you don't know because you don't understand exactly what the code does. And of course, you don't have yourself enough knowledge to debug it at the end. So these people are developing and then deploying basically black boxes without any control.
Yeah, it reminds me of something I saw recently in a workshop where we were testing out the auto suggest feature, auto security suggest feature inside of GitHub to say like it added like 15 lines that would sanitize this output. But when you step back and looked at like what it was outputting, it's like this was a demo app to like literally try to output the password. At no point did the AI like have the context to be like, why are you doing this? This is a really bad idea. And it's that missing base level knowledge that humans just naturally build up over time. Anyway, waxing poetic there. Moving on to actually solutions for this stuff. Again, if AI is not actually solving this, at least not right now, and at least not in a scalable way, then one thing that we do believe is helping with this is putting in proper use of vaulting. So let me get the slide moving. Here it is. So properly using secret managers. This does help with that secret leak a great deal, but it's not a magic wand, unfortunately. It's just not. We would love it for it to be. We have a poll around this. I will go back to the screen here and let you screenshot that or what have you. But let me publish this poll real quick. Publish poll. We want to know if you how your situation looks out in the world. But let me go back to that other screen. Yeah, we were actually a little surprised by this. Like we're still seeing a number of people adopting these and still leaking secrets out in the world. But yes, I'm just going to throw it to you. Like this is something you've spent a lot of time talking about and a lot of time working on. And I'll just give the floor to you.
Yeah. And actually, the example I gave earlier with that consulting customer I worked with is the exact example. It's like we were using a secrets manager, but we were like, and we were keeping things secure, and we had policies on like who could access them, but still like because it was a like development environment first and reuse kind of thing, and the secret was being used by a human, it still got leaked, and it's these kind of things like it's your secrets manager is as strong as who has access to it and what has access to it, and it all boils down to that one. If everybody has access to it, it's like not that secure anymore. And like then everybody can start reusing it. But you also need to have decent policies in place for populating an initial secret and governing all of that secret. And Dwayne, I don't know like how the poll is going, but I'm going to guess a lot of people are going to have answered they have multiple secrets managers in their company.
One system for the entire org is actually tied for first. Between 2 and 4 is the next. 5 and 9 has only got 1 vote, and 10 or more got 1 vote. So only 8 votes so far. Poll still open folks. You can still participate, but that's where we stand at the moment. 2 to 4 is the lead.
And that's what we see as well. Is like a lot of our customers have multi-cloud strategies, or they just have like development teams that have their own secrets manager. They bring like an open source one, and then another team might have like something else, and you end up with all of like these kind of silos where secrets are being managed, but they're not actually being properly governed. And with properly governed, I mean like who has access to them, how are they getting rotated, what's the policies applied to them, all of that, and even not necessarily under control of security teams as well. And that's kind of solutions where we with CyberArk are looking to, like with our Secrets Hub, for example, is trying to manage all of these kind of things from a central location. But developers can still use their own secrets manager, like an AWS secrets manager, a GCP secrets manager, without any problem. And this also brings us to like one of the I'm coming from a cloud native background. A lot of our my colleagues and who I worked with very closely over the last 7 years as we joined Venafi and then CyberArk. We are cloud native experts, and we do a lot of general Kubernetes consultancy, more than just like the CyberArk projects. We do everything, like we do the pure platform engineering, and we see a lot of things around like how mismanaged secrets are out there. And we decided to create this white paper as like it really neatly aligned as well with like the business model of CyberArk. And the thing is like where we started is like how in Kubernetes, like how where secrets are getting stored. And we see customers doing that in like just Kubernetes secrets unencrypted or in source code, to like some customers are already using a secrets manager, to even some customers moving to Kubernetes service accounts token and using those Kubernetes service account token to authenticate themselves to external services. And we created like this kind of maturity matrix where we focused on 5 key areas: the secrets, distribution and access, lifecycle management, identity, governance, and compliance, and created this like maturity matrix to like kind of get to a level 3 and the things like that. And this allows like people can just download this and they can kind of self-identify themselves on where they are and then start tackling these problems. We can of course also help with that with our consultancy team to like we have solutions for covering that, going from our CyberArk Secrets Manager to our Secrets Hub, and to the new initiative which I'm part of, which is a workload identity, where we're trying to get like make it very easy, like and it goes back to the problem of like we now have like all of these long-lived secrets out there, and we are scared to rotate them, like and where I was saying like rotate them very quickly and very much, and that's one of the ideas of like what I'm focused on is workload identity. Like these problems I encountered with the customer were actually for me the feeding ground to start looking into like workload identity, and especially open source technology like based on open source standards like Spiffy, because like it gets rid of like those long-lived secrets. Your key material goes back to like a couple of hours and they automatically get rotated, and you build automation either into your application or next to your application to make sure that they always get like the latest key material, and it relies on existing standards like JOT tokens, which we very much use already like for human identities, to like X509 certificates, which is again like some part of our bread and butter. And it's like an exciting time because like some time ago I went over the OWASP top 10 in relationship to Spiffy, and it kind of stops all of these kind of things, almost all of them, at their tracks, because like they're short-lived. They're really attached to an application, not to either a human or a service. So like from the moment that like a service gets decommissioned, the secret key material is gone and you cannot like exploit it anymore, and like all of these kind of things. So it really helps with like covering like the top 10 of OWASP.
Excellent. So that handles a good chunk of what we're talking about, like the properly storing. Now we're in a position where we can rotate quickly and we can start governing these things. But the one that is not really on there is like that's still that human use. Like that's something that we need to better monitor and have better ways to look for that anomaly. And that, Thomas, that's why you're here to talk. Not to steal your thunder, but that's what we brought you in to talk about, that problem. So let's go ahead and move forward on that. Let's get to the next slide.
Yes, once you have detected with GitGuardian or else that a secret has been leaked, whatever the way it has been, you have to pass through a lot of audit logs, or the cloud audit logs, access logs, sys logs, security logs, a lot of journals with data explaining what has been done with which key, which API endpoint, and so on. It's always better if you have systems to continuously monitor that kind of stuff. You may have an SIM, you may have some alerting system or else. One of these solutions to detect on the fly which strange accesses have been done, what suspicious events have occurred inside your platforms is, for example, Falco. Like I said before, it's a Cloud Native Computing Foundation graduated project now. It's there to detect in real time suspicious events, possible threats that may happen in Kubernetes, Dockers. Basically, as long as you have a Linux kernel somewhere, you can run Falco and use its whole engine to detect suspicious things. It started by collecting syscall from the kernel with eBPF, and applying some rules over these collected syscalls to detect some patterns. And 3 years ago, we introduced a plugin system to be able to collect into Falco any kind of events you may have. So as long as it's an event, you can collect it if you have if you have already the dedicated plugin for. So, for example, we developed plugins to collect the audit logs from the Kubernetes control plane for managed clusters, EKS, EKS, GKE, or else. We also provide plugins. And for example, we also developed 2 years ago a plugin for Okta. Maybe you remember 2 years and a half, 2 years ago, Rockstar Game, the biggest video game editor developer in the world, the creators of the GTA series, they faced a big leak about their in-development game called GTA 6 that should be released in 1 year. It might be the biggest. It's the biggest game ever made in the video gaming industry. And they faced a big leak, or a lot of in-progress material has been online. I've been online, and a lot of people got new information about the game. And they discovered after that someone with some social engineering and some well-crafted phishing was able to get some login password from one employee at Rockstar. And Rockstar is using Okta as SSO, single sign-on platform, to manage all the accesses to their VPNs, to their platforms, and so on. And someone in the company received a lot of requests for MFA requests on his or her mobile phone. And at the end, totally exhausted by all these alerts, finally he clicked on the approval button, and the hacker got access to the whole platform. This pattern of attack, we call that MFA fatigue. And so just 2 days after this major leak and the incident report explaining what the attacker exploited, we developed a plugin to collect audit logs from Okta in real time and detect in less than 1 second all attempts to exploit the MFA fatigue attack. And then you can fire an alert and basically do whatever you want. This is just one example among a lot, how you can correlate or you can exploit all these logs with a system to detect attacks and attempts or even exploitations of leaked credentials in real time.
Excellent, man. Like this just brings us right back to alerts, but this is alerting for someone's actually exploited, something's actually gone wrong. You've gotten that far. And back to Mattias' point earlier, if we can get to this world of ephemeral secrets, this is going to be a lot harder to exploit. Impossible? No, nothing's impossible to exploit. There's all sorts of nastiness out there going on, but it does get us back to this alert. This alert you're seeing on screen, this is actual GitGuardian alert. This is a real one that I pulled from our internal system in our NHI team channel. Where that button takes you is, well, how do we deal with this situation of if the secret's where it's not supposed to be? Our NHI is now primed to be abused, and that's what we've built. So give you a quick screenshot. I know there's a lot going on here. Don't get overwhelmed. But this is an actual screenshot from our product these days. So when you get that alert, this is actually where it would take you. And you say, hey, we have this internal leak. It's in 2 locations, both GitLab and there's a Jira out there, plug into a lot of things. But also, we also know this has been leaked publicly. So now this specific Postgres credential, like, we know, well, we got to work fast on this. Now, we haven't worked fast on it because it's been open for a little while. But again, this is a demo thing, so don't worry. but give you all the information you need to start remediating it. Getting an alert should set the wheels in motion. And if you've done the proper work integrating the CyberArk or the Vault systems out there properly, then that automatic rotation should be a function call. It should just be a, hey, we're hit the system, make it auto rotate all of the things, and that's the perfect day to be. But when you don't know that, well, you need to still do the investigation. Like, what does this actually go to? Those questions we asked earlier. When you get the alert, where does this go? Who should have access? What permissions are scoped? Now, I don't show it on the screen here, but for a number of them, we can actually show that piece as well. That's really our goal here at GitGuardian, is to help you solve this NHI problem holistically, not just from did the policy engine correct, but hey, what can we do about these actual leaks, the actual things out of compliance? Even some early warning, putting some honey tokens out there in the world. Shout out to honey token team for putting the early warning sign. So if someone does get into a repository or a private system, and they start trying to verify, validate these secrets they're finding, you should know first. You should know that attacker is in there. So all goes back to the world of alerts and being on call and trying to get the situation taken care of, whether it be at the point where an anomaly has occurred, when you're looking at actual usage with Falco, or you're trying to get everything into one place and then put the governance rules and auto rotation in place and move to a world of ephemeral secrets with the CyberArk. We're here to fill in the rest of those gaps. So when you're going down the NHI top 10 and really all the top 10 lists from OWASP, which I highly recommend, if you need a starting point on how to think about your security and your organization, OWASP is a great place to start. But as you're trying to answer that, we're here working as an ecosystem, as a team, really, is to help us all stay safe. And that brings us to the Q&A. So with that, we will open up the floor to the questions. I know we already got a couple out there. Let's see. One was asked about GitGuardian specifically, and looks like my team is already on that. We contextually scan for secrets, not just looking for pattern matching. That's the short answer to your question, Rapana. All right. Access permission secrets. That's a good question. Only thing I know for sure is that it's the LLMs are hallucinating more than they were before. I just read a report about that, so I haven't verified that fact myself, but I read a report, I think on Bleeping Computer, that suggested that like, why are we increasing the number of hallucinations? So I don't know. Your general gut feelings on that, Thomas? Yes.
To be honest, I don't really know, because as long as we don't have full control over the models, over what they do, except by running them 100% locally, we are not really sure what they will collect and send to somewhere else. So even by considering the least privileged method, which is just there to scope as much as possible the permissions to some keys or credentials, I don't have a clear answer right now. It's too fresh in my mind what we can do with LLM.
Yep. Mattias, do you have anything to add? You're on mute.
Yeah. The way I look at it, at Copilot, is like Copilot needs to learn it needs to learn from somewhere. So like it gets trained upon I think all of the GitHub public data kind of thing. So when it gives you for example, those API keys and stuff like that, it can it can propose them, but then you can also fill them in yourself and do these kind of things. And it's making sure that you reread all of what Copilot outputs and does these things. I know we, for example, and that's more on the CI/CD side. We have some tooling that can help with, for example, when you accidentally output secrets in GitHub Actions, for example, that it gets that it get cached and then obfuscated. It's not a hard stop, but at least it minimizes the impact. And it's kind of you were saying that very well, Dwayne, earlier. It's like all of these kind of things we've been talking about, it's an end-to-end solution. It's not like I do one of them and I'm done. Like it's like you need to go to multiple steps, and it's like kind of this layered onion of security, and it exists out of like security and depth to do this well. And don't rely only on like Copilot to generate all of your code and blindly take this in. Like you really need to think still, and I think like that's definitely our added advantage of real humans still.
Absolutely. But thanks for bringing up tooling, because I didn't even think about that. But how you prevent that from being a problem is if it hallucinates or it tells you, hey, hard code the secret, and you hit save on the file, there's not really a problem. The problem comes when you actually push that commit that you make away from your machine. Now it's a problem.
Yeah.
So that's actually our entire logic behind GG Shield, our pre-commit hook. So we have a pre-commit hook anybody can use that will just stop you from making a commit that's got a secret. So if Copilot did suggest it and you did try to commit it, will stop you right then and there. We actually have a pretty awesome VS Code extension that actually runs that check on saving the file. So it's not a blocker. It doesn't block you from saving, obviously, but it puts a little warning at the bottom of the screen in red. It's like, you have a secret in this file that you just saved. So even before you get to the get add step, hey, looks like we got some love for GG Shield out in the comments. So thanks very much for that. We really appreciate those kind comments. There was a question, I think, earlier. Oh, it was a comment, I think, that maybe merits a little discussion. We love open source packages. This is from keep scrolling. Akshat. No, that's not. He did say Akshat. We love open source packages, but open source can also be a security risk. I think it can bring a security risk just like any technology can. Like the fact that the distribution model is you can see all the code, I don't think is the risk itself. Not for the vast majority of cases, it's what you did with it. Just curious your gut feelings on that, Thomas.
The obfuscation is for sure not a real way to secure programs and softwares. Having open source packages, tools, or else, of course, it will be easier for the attacker to find bugs in the code base because they have access to it. But it also means more people will have access to this code base and will discover these bugs, these flaws, and they will propose fixes. And if you take the biggest projects in the world, especially the one in the CNCF landscape, for example, at least all graduated projects, to get the graduation level, it's a requirement for them to have at least once a year an external audit for the security aspects. So I'm not sure all proprietary softwares have this level of security. And so if you only consume and use pretty well infamous softwares, at least you have this kind of securities.
I would say, like in general, like the level of codes that probably open source has been generating is way higher than internal projects, because we know as developers that things are going to be open and can be seen by everybody. So we're more, I feel like, internally incentivized to write higher level quality of code, and maybe a small script that we write internally and that's get like locked down within a thing. And it just provides different attack vectors, kind of like where in open source there is like this huge pressure on like securing our software supply chains. We saw like the TG actions quite recently, but also like I think it was a year or 2 years ago, like we had like this state hacker that was trying to as a maintainer try to like smuggle in like some hacked code kind of as part of an open source package. Like they are quite, and it's like the same things that are even happening with like private. There was last week within this blog post from Kraken where like a state actor was trying to get hired into Kraken to then maybe steal some crypto coining and stuff like that, because Kraken is a crypto is based in the crypto space. So like a lot of the same things come back, like they're just different, and I don't think like open source is less secure or more secure. It's just different challenges sometimes.
Yep. Some commented that actually again, catch 22. Some people might overlook like we saw recently with the 7-year-old Linux kernel bug. Yeah, 0 days are out there, folks. We're never gonna be able to stop them because you can't predict them. Like that's kind of the whole point of them being 0 days. Nobody knows about them.
But then with proprietary code, you don't necessarily know if there is any backdoors in it because you don't have access to them. So
yeah, time for one last question, and of course it's going to be about AI. But G asks us, has AI armed hackers with enhanced sophisticated attacks? Short answer is just like every manual ever produced and just like every open source project or tool on the market, in some way an attacker is going to figure out how to use it. Is it making them better at their job? Well, they're also suffering hallucinations as well. The same problems of this package doesn't really exist, or this technique sounds like it should work and it has no hope of working because that's not a real thing. So I think it has, but no deeper than really any other technology really has enhanced the attackers. What do y'all think?
I think AI will not bring more technical attacks, but the phishing attack will be more well crafted. They will provide, basically the phishing emails will contain less grammar mistakes, and the templates will be better, and the phishing website will be better cloned. Right now, when you see a phishing website, it's only 1 or 2 pages. And with AI, they will be able to replicate from A to Z a global website with all interaction into the different pages. And it will be harder for people to detect the fraud because everything will be well better designed, basically.
Yeah, I'm not that close to like the day-to-day like hacking thing, but where I can see AI play an important role at this moment already is like it can sift through large quantities of data really efficiently and answer questions. And I can see, like, for example, feeding it logs and stuff like that to maybe figure out like some things, patterns, or maybe like some accidental leakage kind of thing and give us these answers quite efficiently instead of like manually needing to go through. I think like time will tell. I can see like AI getting better and better and thus like becoming, as for the can be like an added value tool for the defensive side. It can also be an added value tool for the offensive side kind of thing.
So very much this just goes back to getting the basics right. If we don't leak our secrets out into the world for attackers to find them or manipulate LLM to spit them out, then we're going to be safer. If we properly store the secrets in a way and move toward a world of ephemeral secrets like you're working on over there in CyberArk, and if we monitor for the right things, we're looking for anomalies in the correct way. And speaking of open source, I forgot even to put the link to Falco. I've added it now, but you talked about using good supported open source that we know is safe because the community has tested this out. Like Falco is a great example. The Cloud Native Security Foundation or Cloud Native Computing Foundation is a prime example of open source done right at scale. But if we just nail the basics, and it's not like we don't know them, the top 10s existed for a long time. We keep updating it. We keep coming out with new ones, but the basics are the basics. Don't let your secrets leak, store them properly, and watch for anomalous activity. That's kind of it.
Yeah, and not only do it once, do it continuous. That's an important thing.
Yeah, security is a process. It's a long-running process, not just one action.
Well, thank you very much for being here, gentlemen. In the last 2 minutes, you got anything else? Anything else you want to say, Mattias?
Thank you.
Thank you all for attending. These were like some really great questions and a really nice conversation. And I want to say like thank you.
All right. Well, thanks everybody in the audience for being here. We've had a great time. I've had a great time with this webinar. So again, this replay will be made available to you all. If you signed up, you will get an email from us. So thank you very much, everybody. Have a great day.
Thank you. Bye.